In our previous example, I failed to mention one important fact, and that is that every ordered pair on or below the boundary condition line is a solution to the inequality. So anything that's in this yellow region or half plane is a solution to our original inequality. So every ordered pair, in other words, if we chose the ordered pair 1, 1, it's a solution. If we chose the ordered pair 6, 2, it's a solution. On the other hand, if we chose the point 6 or 1, 6, 1, 6 is not a solution to this inequality. And you could make some substitutions in the original inequality and determine that that would be a true statement, that 1, 6 would not be a solution. Okay, let's move on to another example. And we're still graphing inequalities. So let's graph an inequality that is in slope-intercept form still, but does not have the equal part in its comparison symbol. So we'll graph the slope-intercept form y is greater than 4/3 x minus 1. Still using those 3 steps that we identified in our first example, let's draw a coordinate plane. As always, we'll identify our x and y axes. Next, we're going to plot that point that is the y-intercept. We look at our equation or our inequality in slope-intercept form, and we recognize that the y-intercept is -1. So we'll plot a point at -1 on the y-axis, and that identifies our y-intercept. Now we look at the slope value, our m, the coefficient on x, and we see that it's 4/3. So we can tell from the fraction, that's the slope, that delta y is 4, positive 4, delta x is positive 3, so we're going to count up 4 and write 3 in dealing with our slope triangles. So up 4, 1, 2, 3, 4. Notice that I started with my pencil on the y-intercept that was plotted, and now we're going to go right 3. Right 3, and there's a second point. Start with the point of our pencil on that plot, the point that we just plotted. We're going to count up 4 and right 3 again. Up 1, 2, 3, 4. Right 1, 2, 3. Plot another point. And now we're going to connect these points with the boundary condition line. Notice that our comparison symbol does not include an equal sign. That means that we're going to have to connect these points with a dotted or dashed line. So it looks like this. I'm not going to use a solid line this time. Again, we're using a dashed or a dotted line to connect the points. And this is because this boundary line is not included in the solution. So our boundary line, since it's dotted or dashed, is not included in the solution of our inequality. Now we're going to think about which side of the coordinate plane is the half plane that's the solution to the inequality. So like our previous example, we're going to substitute 0 for x and 0 for y, and if we get a true statement, we know that side, the side of the plane that contains 0, 0, is the side of the plane that's our solution. So substituting 0, 0, 0 is greater than 4/3 times 0 minus 1. Well, we know that 4/3 times 0 is 0, and 0 minus 1 is -1. So is 0 greater than -1? That is a true statement. So we know the point 0, 0 right here is in our solution. So we're going to shade the half plane that contains 0, 0. And it looks like this. Shade this half plane that's above our boundary condition line that's dashed or dotted. And we know since it's dashed or dotted that any point, any ordered pair lying on our boundary condition line is not, again, is not a solution to our inequality. So any ordered pair that's a solution to this inequality must be above the line, above our dashed line.